Hey, my name is James. In this video, we're going to be looking at DeepSeek and exactly how you can actually install DeepSeek on your own computer so you can run it locally. DeepSeek was launched a couple of weeks back, and it has sort of sent shockwaves through the AI industry. We can see that in the NVIDIA share price, which I believe lost about just under $600 billion because of the release of this. And if you want to see more into exactly why DeepSeek has caused so much turbulence in the AI industry, I will link to a video from Computer File in the description that you can go and view. And it's go into a lot more technical detail about DeepSeek and why it is different from ChatGPT and a lot more of the technical things. So DeepSeek have released two versions. So there is V3 and there is R1. V3 is supposed to be more like ChatGPT's 4.0, and R1 is a reasoning model, which is more like ChatGPT's 0.1. And if we look at their website, at the release, we can see that it's supposed to be on par. It's supposed to have the same performance as OpenAI's 0.1, which is great. And because DeepSeek do all of this with less need for computing power, and they made it open source, what that means is that access to run these AI models is now available to a lot more people. Whereas OpenAI keep all of their code and their models and everything behind their closed doors, DeepSeek have actually made it available for anyone to run on any computer. So that's what I'm going to be going in today. How do we actually install that onto your computer? They do have a chat bot version, which is free, and you can just go and chat with it, and you can ask it a question. You can also use the DeepSeek R1, and this is free. They haven't asked money for this. And they have an API as well, which for the developer side is kind of a big deal because their API costs are significantly cheaper than OpenAI's API costs. So if you're running a service that links to an LLM and you have a large customer base, using something like DeepSeek instead of OpenAI or Claude, you can potentially save on significant costs, because as one article I read, you're looking at about 27 times less cost in DeepSeek than you are in OpenAI's 0.1 model. So if we look at the prices from the DeepSeek site, we can see that their DeepSeek Reasoner has a input cost of 55 cents per million tokens, and their output costs per 1 million token is $2.19. So if we look at OpenAI, what we can see is that they have a $15 for 1 million token input, and output is $60 per 1 million output. Now, that's obviously a significant price difference between DeepSeek and OpenAI. But probably the most interesting feature about DeepSeek is the fact that you can run it locally. And how we're going to do that is you're first going to need to download Ollama onto your computer. So you can just go to ollama.com and you will click the download button, and that'll download for Windows or Linux or Mac OS. And it'll just have a little install file, and that'll install and you'll be done. Then you can come through to the Ollama library and find the DeepSeek R1 library for Ollama. And they have different parameters. So they have a 671 billion parameter model. And then they've got smaller models as well. So 1.5, 7 billion, 8 billion, 14 billion, 32, and 70 billion. And it would really depend on your desktop setup and what you actually have, what computer you're running, and if you have GPUs available to use. Myself, I'm actually just running off a 2019 MacBook Pro. It's nothing special. It's just a very, very standard MacBook Pro from 2019. So running the larger models for me would be difficult, but I can run the smaller models. So what you would do is once you have Ollama installed, you can open a terminal window, and you can, if we just say Ollama, what we can see is we can see all the available commands here, and we're going to want to run, we're going to want to download DeepSeek's, let's just download the 1.5 billion parameter model. So we'll come, and you can just paste Ollama run DeepSeek R1 1.5 billion. And what it's going to do is it's just going to download this. So it's going to take a little bit of time. It's a couple of minutes here for me, and it'll download the version that you have chosen. Now that we have DeepSeek downloaded, we can actually just run commands straight from here. So we can just hello, and it's going to give us an answer. Now this is only the 1.5 billion parameter, so it's not going to be as good as the other ones, but it's going to be much, much faster, especially for me. So I have multiple versions of DeepSeek enabled on this computer. So if we just run, so I've got the 1.5, the 8, and the 14 billion parameter. Now we can actually see the difference in speed for those. If we run, let's run the 1.5 billion first. All right, we're going to give it a longer, we're going to ask it to give us a longer response. So we can see this one is reasonably fast. What did I say? So we can see this one is reasonably fast. I just asked it to tell me about South Africa. So it's just going, it's giving a whole bunch of information. I'm not going to confirm if this is correct or not. We're just going to look at the speeds for now. It's probably not going to be 100% because it's a much smaller model. So what we can see here is the output here was 21 tokens per second, and that was quite fast. So that wasn't sped up in any way. We can see that just running normally. Now, if we cancel that and we have the 8 billion parameter as well, and we run this, so we can see that this is much slower. Let's just look at the response. So it is definitely a better response. It is definitely more thoughtful, this response, than the other response, although it is not 100%. It is saying some things that are not, that could be better. Let's speed this up to the end. All right, so what we can see is that with that response, with the 8 billion parameter, we only got 5.15 tokens per second. With our previous one, we've got 21. So a lot slower on my machine. That obviously we would expect that. Although I still feel like this 8 billion parameter one I could deal with if I was doing something that I wanted to use a local LLM for. The 14 billion parameter, this is going to be very slow. So let's check that. I made the prompt a little bit smaller, just so we don't have to wait, because I know it's going to take a long time. Okay, so what we can see is this is significantly slower. So what we can see here is the actual reasoning that it's doing. So I've asked it to tell me about South Africa in 100 words. And what it's doing now is, before it's actually giving me an answer, it's actually reasoning. So it's doing what O1 would do, but we don't actually see it with O1. We just see sort of a light version of what the reasoning that it does, where this is actually going through the steps as sort of a human would, where you would say, okay, I'm going to summarize South Africa in 100 words. So what should I start with? What are important things to mention? Nelson Mandela would be important things to mention. Mining might be an important thing to mention. Its place geographically would be an important thing to mention. And what else? Diversity and all sorts of things. So it's going through a reasoning step. So now that it's actually gone through that reasoning and it's thought of what it should place in a 100-word summary for South Africa, it can now actually do that summary because it knows what it wants to talk about. So now what we can see here is it's finished the think part of the step, which is the reasoning part that it goes through to get to its answer. And now it's actually formulating the 100-word paragraph about South Africa. What's quite interesting about this reasoning that I noticed here is it does it very much like a human would, where it says things like, I remember that South Africa is known for its diverse landscapes and cultures. That is like a human-like response that you would have, where you say, oh, I remember something about this place. I'm thinking about it. Let me see what I can remember. So it's interesting that it's phrased it like that. What we can see here, obviously, that now that it's done, we can see that this only had a 2.9 tokens per second response rate, which is much slower, but this is a much better response. So as you go up in this, you are going to get better and better responses, but you are going to need a better and better computer or a setup where you're going to need some graphics cards to actually do this for you. So if you have a nice gaming PC, you might be able to run a larger parameter model here. You might be able to run the 32 or maybe the 70 billion parameter and get really good answers from a locally run LLM. Thanks for watching, and maybe you want to watch some of my other videos where I create applications and games using AI models, and I use all different kinds and test all different kinds to get the best responses in the quickest time and build those out to actually working apps that are online for anyone to use. And I do that in the shortest amount of time, and I show you how to do that. So subscribe to the channel if you want to keep up with all of that. Otherwise, there's some of my other videos which you can go and watch over here.